We're going to talk a little bit about the project that we are doing at Telefónica de España, if I can manage here. First of all, I want to thank both Maria Garcia Osma and David Artuñedo Guillén. Maria is the technical director, or the director of the technical team that puts all this together. And David Artuñedo is the technology guy, director of technology that has made it possible. I am the guy that steers them up a little bit and asks them to do things a very simplistic way and have them explain me why we have to be complex, and sometimes they manage to convince me, most of the time they don't. At the Mobile World Congress in last February, Telefónica presented, here is Juan Carlos Garcia Lopez, here's on the picture there. We presented a prototype of the open access architecture. And this is quite a promise from Telefónica on disaggregating the access network, the pieces that today are monolithic solutions, and we're disaggregating them. We're breaking them apart, breaking the hardware from the software, the control plane from the data plane. And our project, the OnLife Networks project, is the glue that aggregates everything that has been disaggregated. You disaggregate, you break it into pieces and parts, but somebody has to put it together. And we have an internal project that, using SDN, cloud, and some IP protocols and OpenFlow, puts it all together and makes it work like it was, and provide the same services and further more services than we had before. So, and besides that, when we start doing the project and putting all these pieces back together, disassembling them and assembling them, we figure out that we were already at the central office and we were at the very edge. And when you are at the edge, we said, well, why don't we provide, and we have a cloud environment to aggregate, why don't we provide edge computing capabilities? This is way before terms like MEC or anything that you hear today was on vogue, and there was no standards or specifications. That's what I mean, that the center of the talk is that sometimes when you innovate, you can't wait for standards or for some ideas to be put in paper, and it's better to move forward and try to come up with a solution or a vision and bring it together. How many of you are familiar with the online network projects? Okay, just a brief explanation. What we've done is we got to the fiber optic access network that Telefónica has in Spain, and we decided to make it fully programmable from the household all the way to the central office. One of the main ideas that we have, that we have learned from previous projects in the company, was that we could virtualize the CPE and then extend the network, taking advantage of the fiber optic, extend the network all the way to the household or to the location of the customers. So that's what basically the project started to. That's what we got money funded for, and that's what we achieved. And we have right now a pilot running in Telefónica de España with residential customers, and now with starting this week with one enterprise customer, which is quite an achievement because I'll explain you briefly what we're doing with them. And as a matter of fact, we are starting a pilot in Brazil this year. I just arrived from Brazil at 1 o'clock this afternoon, so I can assure you that we're starting the pilot there. So what was different of a technological approach, just a pure technology, let's disaggregate and keep the network the same it was, but with different components. The area that we work at, was used to call customer-centric networks. Now it's called Networks Innovation. And so we started the project focused on the customer, what we could do for the customer, do a lot of UX, talk to them and see what was needed, both on the residential and on the enterprise side. How could we do things better for them? And that brought us to one dilemma. The way that traditionally specifications, standards, and these things are developed have nothing to do with the fast-growing necessities of the internet users. We either move ahead and start behaving more like a Google or Amazon, or Facebook provider, service provider, than a traditional telco provider that is always looking and working, waiting for standards to be developed and then come up with a solution. We decided to work on the solution first, see what the vision, what the customers were looking for, and we brought upon a solution. So, but at the end, how do you must choose some standards. I mean, you cannot just go in there and say start everything on greenfield. So we kept the idea that we wanted to extend the cloud to the neighborhood, to your doorstep, and that will keep us keeping one thing in mind, that will lower the latency to a point where today we are proud to say it, or glad to say, that our edge computing project in Peñuelas is about 2 milliseconds away from a customer device to a virtual machine running in the central office, which is unheard of, and it really brings very new opportunities for not only for Telefónica as a service provider with the services, but for third-party providers. So how do we build a standard around it? There's no way you can really standardize that, because each telco will have its own topology of the network and will have its own solutions. And it will be very difficult to say, every one telco will have the same latency, but we are able to achieve that with our fiber optic network. So that, becomes a de facto standard, or somebody's going to put it in paper and propagate it. Very hard to say. So what we thought is, we gave the team the liberty to thought everything they were going to do. How will they simplify the network? How will they take away different components? Since we were creating a new programmable network, we said, let's just use what is really needed to provide connectivity, video, voice, and that way we had some constraints. We had an existing PON network with a 164 to split. We had a GPON network with a possibility of extending it to XGS-PON, so we worked on that as well. And we have central offices that are already built and have their constraints and their environmental conditions that we had to put up with. Okay. And the fundamental thing that we use, the fundamentals of design we use, everything had to be IP, so that was one standard, IPv6. SDN, we were going to use SDN throughout, making all the connectivity software defined, and that there is no standard for SDN. There's many approaches to SDN. There's many solutions, but there's not one single standard. So we chose one. We chose ONOS for that. Also, we decided very early on that everything had to be open source. White boxes, so we choose for the infrastructure Open Compute Project infrastructure. At the time, we were lucky enough, AT&T was specifying the GPON OLT, so we took that upon ourselves to make it work and connected to our network successfully and to our own home gateway unit devices that we had already in production. And for the cloud environment, for the Veeam, we used Open Nebula and used as a hypervisor KVM. So those were more or less the 4 or 5 standards we decided to follow. Of course, within those standards, you have OpenFlow, you have OMCI, you have different standards, but everything was geared to let's make the customer in charge of his connectivity. And what we showed at the Mobile World Congress was that the customer really can interact with the central office, with their virtual CPE, do the changes they need to change velocity, do the self-configuration of the routers, and that allows us to provide them enough capabilities, and also true zero-touch. Since we're in a zero-touch Congress, this was a true zero-touch, allowing them to do changes, and the idea that we have is that the changes they make to the services, instead of the traditional way that today we go top-down, first you contact the BSS, and then that cascades down all the way to the element doing the service. The customer is contacting directly the service element, and then the billing and the CRM will be notified after the event is completed. So it's a complete change in paradigm, and we think that that's something that we're exploring, and that's something that will be really change the way we are used to provide service. I talked a little bit about what we've already done, but let me go into more detail of what we have achieved thus far. We did a lot of the work, and it was not only our own thinking on how to come with solutions. We studied a lot of the preliminary work done by DT and Verizon. DT's TerreStream project was very inspirational for us, and Verizon at the time also was working very hard on doing virtualization of their central offices and trying to move data loads to virtualized servers. So we took that, we learned a lot about them. And then working with AT&T, we came up with closure solutions using the core architecture from the Open Network Foundation. And then at that time, when we started developing the project, we did a change in the philosophy of the project and said, this is not only about cost savings, this is not only about being more, having more leverage with traditional vendors or with new coming vendors. This is also about adding value to Telefónica's proposition. The main mandates we got from our directors was that anything we do had to be capable of bringing new revenues to the company. And to do so, we had to really think out of the envelope. There was nothing that we could do to try to just change the existing infrastructure with this new infrastructure if at the end there was not going to be any revenue. So we had two mandates. The solution could not be more expensive than what we already have running, and it must generate new revenue and with higher value than anything that will substitute. There's services that will be substituted by this kind of solution. So we had these two mandates. And at the same, and one more thing added was how do we put in value the lower latency that we are able to provide with this solution? That's something that's not been put into context yet. The difference was an earlier discussion about being on a centralized public cloud versus a telco data center versus being in a central office. I just mentioned that day latency, the pings that we're doing between virtual machines and devices at the customer's premise are 2 milliseconds. Any public cloud today, doesn't matter how close it is to your to your location, is between 50, 100, 150 milliseconds, depending on the location. And to a telco data center, well, it's probably in the 20s as well. So offering 2 milliseconds must have some value. We have not decided what it's going to be, but sooner or later we'll have to come up with that and confront that situation and try to resolve it on the best possible manner. Definitely, we are open to use standards. It doesn't mean that we neglected or to say we're not going to use any standard. There's going to be a free-for-all, and we're going to create a new solution. And if somebody likes it, we'll take it upon and use it. But we will use standards that really help us to achieve our objectives. We will not use standards that are not there to be, just because it's a XYZ standard and it's a must. And if it doesn't add any value, we don't need to. And the way we confront this is because what we have achieved is to have a fully programmable network. So we can program to any existing or future standard that's out there, and we're not afraid to make those changes. When you own the capacity to program to something, you can really make the changes to get there. And that's one of the basics that we use. So if tomorrow there is a new standard for, I don't know, Maria, what can we think? we don't want to mention names, but if there's a new standard for something, I don't know, for home connections, and we need to modify the way we have programmed the access to the home, we will do so. If there is a new API that we need to connect to because it's better than the previous one, we will program to it. But that's key to it. And, when you can program things, you can really abide to any standards. We're working with Telefónica de España on how to use better the central offices for data processing. And of course, there's standards that data centers have that central offices don't have. And we're working on that, and we'll try to comply with them in the manner that they add value to the proposition that we have and to our solution. But there's going to be some give and takes on what can be done, what cannot be done, what data can store, what data cannot be stored. But that's workable, and we think that we can move that way. What did we decide to use for this prototype project and for this innovation ideas that we had, this innovative solution that we had? Well, as I think I mentioned it before, we definitely used IPv6. We said that from very early on, IPv4 is a service. IPv6 is the standard protocol that we use for communications. And that has proven as of late on 2 use cases that we're developing that's the way to go, and we're quite glad that we made that decision. We used OpenFlow as the protocol for data plane separation from the control plane. I know there's other standards coming up. There's maybe P4 or other things that could be useful, but for now we're sticking to OpenFlow. It's proven quite good for our SDN control of the switches and of all the switching devices and the OLT. So for SDN, I mentioned before, we use Tonos. Our architecture is very similar to the residential core architecture. We changed a little bit because when we started the project, core it was not IPv6 compliant. It was only IPv4. So we have come up with our own solution of, if you know core very well, of Trellis or VTN. We have a solution called Close Forward that we will be publishing in the coming months, and for the good of the community and people that want to have a very dedicated central office IPv6 based closed fabric control system. That will be available for you to take advantage of. Then for switching, we use ONIE and Open Virtual Switch. These are also standards. I mean, they're not published standards that you must use ONIE if you want to do it, but there are things that are available there. Open Virtual Switch is another one that we used. Then we used, as I mentioned, KVM and Veeam. We used Open Nebula, but with KVM we could use also the hypervisor from VMware under the same cloud management. And all the equipment was Open Compute project. We were very adamant from the very beginning that was something that we wanted to test, not only for the benefit of the project, but to see what OCP had to offer on a central office environment where the environmental conditions are not as strict as in a regular data center, and it's proven very good for us. We had a couple of air conditioning outages on the central office, and the equipment kept on working while other pieces of equipment were being shut down. What we left behind? Well, we left behind. We have not implemented MPLS right now. We don't use Netcom for YANG for modeling. We have not utilized any canned network function. All the network functions that we needed have been reprogrammed and simplified. Once canned network function is available that it is really needed, or the company would like us to use, we'll probably use it. But for the time being, we have used all open source solutions and done things like that. And basically, all we've talked is about the fiber optic access network, PON network. But of course, in the future, there's the aim to move to the radio access network, and because of the Brazil pilot, we're going to have to accelerate that need. So what is going to happen? I put it in Spanish because I love this phrase. Basically, it says simplicity is the definite sophistication, and that's what we're going to try to do with the radio access network. The same thing we've done with the fiber optic network. Simplify as much as possible. Take away layers of legacy, both in the OSS and the BSS that are not needed, and see what we can do to make it a really disaggregated solution, and what software has needed to control this as to provide equal or better service that is provided today by by monolithic solutions. We will do more of the same, complete disaggregation. We will only use what is absolutely necessary to guarantee the service. Any added layers or any added software that is not needed or is just something that comes from the past, we'll probably program around it. And the architecture will be the same that we have used for the fixed access. And if the project keeps on being funded and it's useful for the company, I think we will come up with a very nice solution. But as I said before, this is a prototype. It is an innovation project. It's truly running we have real customers connected, but it is in a pilot mode. So anything that comes on the future is still an unknown for us, and we'll keep working on that direction. So that was basically what I had to say.
Okay, thank you. Time for a question?
Yes.
Actually, hold on. We're going to stand by for recording things. Thank you.
Yeah, Alfonso. So in my previous life, and then when I work in, with previous company, we talk about, we have discussion before. That's about 2.5 years ago, around 3 years ago. Mm-hmm. Everything you said, congratulations. It looks like now you realize IPv6, you want to do white box and all that. Congratulations. But at that time, you tell me another thing you want to do. You tell me you have a way to get rid of OSS. How's that go?
What I'll say is my personal view and only my personal view. So keep it as that. Okay, right now since we're in a pilot with Telefónica de España, we're really starting to understand the complexity of the OSS, and there's many layers and there's many components to them. We're working with them on the alarms and supervision to have this central office, the CTPD, come as close as possible to the front end of their supervisory system, as close as possible. I cannot give too many details; it will be too complex. But actually, the idea is because we're moving the pilot to a bigger with more customers. The idea is that their technical centers will be able to interact with the system almost directly. Okay, so this is what we're working on an API that will allow them to look at the system directly and being able to diagnose like they do today. But instead of going through several interfaces as they go today, they will have one single point of contact with our solution. That we're doing for the supervisory. For the analytics side, they have newer tools that will allow us to take advantage of newer analytics tools and predictive maintenance. So we will connect to them, and we will be constantly delivering data to them. So they will circumvent all the alarms, all the systems they have today to collect data. That's what we're doing with them. On the BSS, we don't know. Telco 3.0 and full stack are complex things, and we don't know if this project is going to move forward. none of them, they're treated as pilots, so the customers we have in there are tendered almost in a personal manner instead of going through the regular BSS, and that's something that we still have to work. But you're right. My idea is that we should bring the central office equipment as close as possible to the CRM and to the, and eliminate layers that are there not because we want them to be there, because they are from other stages of the development of the company. We have still DSLs, and we have our DSIs, we have voice copper or voice over copper. And those require complex systems, and they are still in-house, and we have to come up with a solution for that. And it's not only us; every company that you talked about it, every telco has to look at that. But I think this is the way to go when you can program the central office and program the network. You can help get rid of all those old pieces of equipment or systems.
All right, Alfonso, thank you very much.
You're welcome.
And,